Okay, so this is part 3 of the Microfluidic channel. I'm going to go into Setup, Edit. 3D should be already selected. I'm going to click Double Precision. If you check your system information, you should be able to see your processor, how many. So if you go, sorry, I had to pause that for a second. If you go into your system information, should be able to pull up your processor and see how many cores you have. So mine has 6. So essentially, what this is asking is how many cores do you want to utilize to solve the process? My last computer I had 4 cores, so I would usually just select 2. I wouldn't want to max out the cores. But since I have 6 on this laptop, I'm going to up it up to 4 and see. Hopefully, it'll run quicker. When we utilize FIU's computers, obviously we can use 16, so it'll be even faster. And we're going to click Start. It's going to load in the Setup menu. And like I said in part 2, Ansys does a really good job at recognizing the name selection and setting those accordingly. So like as you can see here, it's already highlighted the inlets and the outlets. So for example, if we go here to boundary conditions and we go to outlet and we double click on this, we're going to see that it's already selected 0 gauge. We can basically keep all this defaulted how it is. If this was flowing into, let's say, a second part and there was a vacuum, obviously we could change this. If there was a backflow, like a resistance, a positive pressure, we could change it. But we can just keep that at, we don't have to really change anything. We just keep it as default settings. So first thing I'm going to go to is general. We're going to make sure we're in transient. This can stay pressure based. This can stay absolute. And we don't have to do anything with the gravity because remember, when we're dealing with microfluidics, surface tension has a lot more impact over the fluids particles than gravity does. So we can keep that like that. We're going to go into models, multi-phase. We're going to select volume of fluid. And this should all be defaulted like this too. Those should not be checked. I think those should all be like that. I'm going to change this to 5 just to keep it the same as before from the other senior one thing we did. I'm going to change to click this implicit body force. I believe this has to do with forces on the fluid, if I remember correctly. Now these sections are grayed out, but we're gonna have to access them. In some of the other settings we do later, we'll open these up so we can go back and change these. So we'll go back to that in a moment. But for now, we can just keep everything how it is. Click Apply. Close this out. We're going to, just bear with me one moment. Okay, so we're going to go to inlet. No, I'm sorry, materials. We're going to open up the fluid. And we see here that air is the standard only thing that we have. So we're going to double click that. And we're going to change this to silicone oil. We're going to change this to, let's see, what was it? 930. We're going to change this constant to 0.01 and change and create. We're going to overwrite this yes, and it's going to change silicone air, fluid. I'm sorry, silicone oil, fluid, silicone oil, 930, 001. Close that, and you can see here that it's changed that to oil. We're going to right click on fluid, click new. We're going to go to the database. We're going to go down to water, liquid, click, copy, close, close. Okay. And we can right click on this fluid, delete it, delete it. So we should have oil and water. I believe, if I'm not mistaken, I just want to make sure that those are the settings that I had in the other section. Yes, okay, close that out. Okay, so next thing we want to do is we want to set what's going in what. So the oil inlet, Let me check something. So my cat's trying to get in the door. Okay, I had to pause for a moment to check something. Okay, so when we open this up and we select the phases, this comes back up. So let's go here to the phase. So phase 1 is the primary phase, and that's going to be, I believe, oil. If I remember correctly, let me look at my notes. Okay, yeah. So oil. So let's name this oil. And then this is going to be secondary water. Phase 2 is water. And let's apply that. So we should have oil as the primary phase, oil, water as a secondary phase, water. And we need to also do the phase interactions. There is a oil and water has a phase interaction between the two of them, and that value is, bear with me one moment. I'm going to select that. And then this is going to be 0.0365. Surface tension force modeling, I think that's what we had did before. Wall adhesions, because we're going to select a interaction between the wall and the fluid later on. Those should be good. And then apply. Okay. So let's make sure. And then that's, okay, so we set our phases. Great. Models. Good. Okay, so we can close that out. Boundary conditions. Okay, so this is something that I had messed up that I didn't quite do before, and I hope it doesn't, hopefully it doesn't affect the thing too much. But we need to set the boundary conditions. Okay, so for the oil inlet, we're going to select the magnitude 0.1236. Click apply. Close that. Did it go? Let's see. Yeah. And because this is oil, this phase interaction it's not there. Okay, we're gonna keep that 0. Actually, I guess, see, I was watching an old video. I guess because, okay, so I was watching an old video and they had selected the oil. So you see here I have the inlet, oil inlet. I selected the velocity, but we need to make sure that we know going through this that we're selecting that it's oil. You could see here that when I click oil, it doesn't come up with any options. If I click water, it comes up with a volume fraction. In the previous video I watched, which was an old version of Ansys, they had selected oil as 1 as volume fraction. A newer video I had didn't have me do it, and that's why I had to pause the video because I was a bit confused. But I believe what happened is because the oil is the primary, and we select that as the primary phase here, and the phases, that it automatically is going to assume that the primary phase is going to have a volume fraction of 1. That means how much of it's going through. The water, we need to select the velocity of the water, which is, let's see, 0.0848. 0.848, right? And we're going to click apply. But when I close this and I click the phases, this is letting the system know what is coming in the water inlet, which should be water. Then we're letting it know that water's coming in. So this volume fraction is going to be 1. And I'm sorry if I'm confusing you guys, but basically the reason I had paused, which you can basically ignore the previous pause, was I think the old way you had to, even though you were selecting oil, you had to select volume fraction of oil to be 1, to letting you know that that's how much is coming in. It's the ratio. But this, since oil is the primary, it automatically assumes that that's the one coming in. And so if you click 0 for water, it's only going to come in oil. If you click water and you click volume fraction 1, then for this one, water is going to be the only one coming in. I believe that's how it works. Hopefully. We'll see. But anyways, okay, so we've done our multi-phase. Just to recap the models: volume of fluid, two Eulerian phases. If we were running the fluids into a tank, we would have to have 3 phases, and we would have to have like air as one of the phases. Obviously, if it's starting with air, you would need 3 phases. We're only dealing with the 2 fluids, so two Eulerian, whatever that word, phases. Volume of fraction, volume of fluid 2. These are all good. We're doing an explicit scheme, which we might, like I said, we might come back and change it. Phases, we have oil as the primary phase, silicon oil. Water as a secondary phase, water. In the phase interaction, which is a constant surface tension between them, 0.0365. We're modeling the surface tension. We're also selecting wall adhesion, which is going to be an option we're going to show later. We applied all that, so everything's good there. These are all good. We selected oil as a fluid. We selected that in the database. Also water and the database. Okay, yeah, so I think we're ready to proceed here. So, cell zone conditions, fluid. Zone name. I'm not sure about this setting because I might have to research it, but we're going to leave this alone now. I noticed that I think in the previous video, let me pause this a second and check again. I'm sorry, guys. Okay, I was just making sure cell zone conditions. I was trying to see you like for the fluid what I needed to have. I wasn't sure. I mean, it says zone name solid. We can obviously ignore that because it's not solid. But the phase mixture. This, I believe, from what I'm seeing, is that what are you going to be solving in the cell zones? Obviously, we're working with a mixture, both. So we're going to keep it at mixture. That's what I did with the last one. So I'm just going to keep it at that for now. I guess if we were, yeah, I think that's it. So I apologize, guys. I'm trying to also work through this and make just as I'm going through because it's been a while. So inlet's done. Okay, so boundary conditions are set. Now we're going to go to our methods. He was saying about doing second order, but if I do second order, it comes up with this warning. It's not available in explicit. So I'm just going to keep it like this for now for this one. This is where I was saying that obviously if I go back here to multi-phase, don't change anything, but I'm just showing you. If I did implicit and I applied it, and then I close this and I do second order, so then it should work. So I think for this one we are gonna go and do implicit instead of explicit, so that way we can do second order transient formulation. If anything, we can go back and change it, but for the most part, I'm at least going through and explaining my thought process, and at least like the phases and the phase interactions, those should all be the same. So we can go ahead and close this. Oh, one thing I forgot to mention was with the boundary condition was the wall. If you remember, we had selected the wall in this section. Yeah, wall adhesion. So this is saying how much adhesion is there a wall? How much will the fluids adhere to the wall, right? And so that's where this comes in for the wall. Okay, so we have a contact angle between water and oil of 140 degrees. Now this was set in the paper, and so that's why I had selected this. Let me just make sure this is standard. That's good. No slip, stationary. None of those. Phase, zone name, wall mixture. Okay, so we're good. So we're going to apply. Close that. And then we're going to go back to the methods we selected. Those are good. Controls. I believe these can all be pressure, density, body force. It's momentum. Yeah, I think those are all the same. Okay, so one thing we want to do is look at So I guess I can't see contours yet. Right, so we want to create an animation, but I don't think we can do that yet because we don't have anything here. So we're gonna leave that for now. later on we're going to have a be able to see like the model that comes here under graphics contour, but obviously we don't have results yet. And calculation activities, we have I guess we're going to, yeah, this is fine. Okay. So to see the steps, I don't know if you guys remember, we could see an animation of what the fluid's doing and coming out. That falls under calculation activities. We would create a, yeah, see, we can't do it right now. We would create basically an animation that we can see. I guess since we can't really do it right now, we're not going to really touch it. So we're going to go to, just making sure we're doing everything. Convergence conditions, monitors, look at the residuals, check convergence, cancel. Think we can change this. No, I'm going to keep it like this for now. Okay, initialization. So we want to check to make sure that everything looks good as far as initializing the flow of the fluids. One thing to look for is you want to make sure that the value is decreasing, right? So this is 1, this is to the -4, -5, -5, -6. So it's decreasing. But you also want to check to make sure, like this is -7, -7, -7, -7. You want to make sure that as it goes down, it's decreasing. So 6.77, then 3.17, it's decreasing. 1.8, it's decreasing. 1.3, it's decreasing. So you want to make sure that as it goes down, it's decreasing. So let's say, for example, if this had 5.122, 10 to the -6, and then this one was 1.7, 10 to the -5, it wouldn't be decreasing. Something would be wrong with maybe the geometry or the mesh. And so, but since it's decreasing, we're good to go. We're going to go to run calculation. Number of time steps, I'm going to do 200. And I'm going to do 200 iterations per time step. And the reason why I'm not doing that many time steps is because it isn't going to take that long to form. I mean, we won't get a whole system, but we should be good. This is going to be e to the -5. 1e to the -5. Fixed timestamp, user persistent. I believe, let me just look at my pictures. I think, did I not take a picture of that? Let me see. Let me look at the video. Okay, so 1e to the -5. Reporting interval. I think he said we don't have to report it. You could report it every 50. And I think we're good to go. So I'm going to go ahead and initialize it, give it a minute to see how it's running. See, yeah, I can't. Yeah, okay. I guess I have to wait for that. Okay, so we're gonna calculate. And it's gonna go through a thing where it says writing, 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 and it's gonna start calculating the solution. Okay, so I had told the computer to basically update every uh, 50 iterations, and so that's why it's not showing anything. Otherwise, it would be showing residuals and whatnot. Okay, oh, see, there we go. So it's actually going at a decent pace compared to before. Um, I have a little fan, I'm turning it on so that way my computer doesn't get overheated. Let me turn down the brightness too. But I'm going to let this run for a bit. I'm going to see what happens. Um, this might not work, it might work, but at least, the things of how multi-phase is set up, how we set up the fluids, the phases, how we did the boundary conditions, the inlets. That all is not going to change. So we can at least um, understand. Okay, so you can see here I said remember 200 iterations, but at 100 the solution is converged. So now it just moved on to the next time step. And the step size is 1 to the negative 5 seconds. So 150. So most likely when this gets to 200, it's going to say the same thing, solution is converged. And then it should move on to the next time step. So maximum iterations, like Dr. Bootson was saying yesterday, it probably won't take the whole 200. It might converge before. It seems to be what we're seeing, um, which is good. Let's see. Yep. Okay. So after 200 iteration, the solution converges, so it moves on to the next time step. So that's good. So, anyways, I'm going to stop the video here and come back later when we have some more results, and we can just go from my camera. There we go. What are you doing? Pause. Okay, so I'm just showing an update of where we're at. There's 81 time steps left. So what I'm gonna do is, because we're about 30 minutes into this video, I'm gonna stop the video, um, and I'm going to let the sim keep running, and I'll close it later, and then create a part 4 to show the results and some other things that we want to look at. If it works. If not, I'll probably I don't know. I might scrap this video. Of course, that means if I scrap it, you guys won't hear this. But we'll see. I'm just gonna stop it for now. And yep. Okay.